Hello, in this video I'm going to talk about Numpy library in Python. Let's get started. I need to import the library, import Numpy as NP, and then I am able to introduce a new array, np.array, and assign 1, 2, 3, 4, 5 to this array, and then print the array, print A. You are able to see the type of this array, print type of A. This is the type of this array. Then we are able to say, for example, print A1 as its indexes started from the 0. 1 equal to index 0 and 2 is index 1. So I just expected to see 2 in here. Yes. Or we can say something like print A for all of the column except the last one. Yes, 1, 2, 3, 4 except the last one, 5. Also, we are able to introduce this type of the array, like a equal to np.array for 1, 2, 3, 4, and the next row is 5, 6, 7, 8, and this one, and the next array is 9, 10, 11, 12, and the next row of this array is 13, 14, 15, 16. Close this one, close that, and that. And let's see, print A. Yeah, and we are able to see what is the A dot. Let's do the print A dot shape, which is saying that it is 2 array, and each array itself has 2 rows within 4 columns. This is the shape, and we are able to say print A dot size, which is 6. Also, we are able to introduce another array like this, np dot full, and we introduce what size of the array we are looking for. For example, I want to have 3 arrays and with 2 rows for each array and 5 columns for each array, and fill it with, for example, 7. I want to see 7 in all of the rows and column everywhere. And let's print A. Yeah, as you can see, there is three arrays in array A, and in each one we have 4 rows, 1, 2, 3, 4, and 5 column, 1, 2, 3, 4, 5 column. And if I want to say that A np, let me copy this one, Ctrl C, and instead of the full, I would be able to just say, for example, zeros, and I don't send anything to that. We'll create the same array, but it fill it with the 0 instead of, for example, 7. As you can see, again 3 arrays, and each array have 4 rows, and each array again have 5 columns, but all of that is filled with 0. I would be able to do it again for 1 like this. Don't say anything to that. It is 1. Also, we are able to create a sequence like x is equal to np range, and the start and stop, for example, from the 0 to 1000, and the step 55. So let's see, and print X. Yeah, as you can see, it's a start from the 0 to 995, and 55 is going up. The other one is x is equal to np dot linspace, and we're able to introduce from the 0 to 1000 again. And for example 5, it's gonna evenly between the number in one array. Let's see, print X. Yeah, as you can see, 0 to 50, 500, 750, and 1000 evenly distributed this one in this array. We have none and infinity concept in Numpy as well. For example, if I want to say print np.sqrt, which is one of the math method in Numpy, -1, it will give us the none result. And if I want to say, for example, print np array 10 and divide by 0, divide by 0 is going to be infinity. Yeah, infinity. And I'm going to just introduce L1 as a list like this, 2, 3, 4, 5, and then L2 like this one, equal to 6, 7, 8, 9, 10. And then let's see, once we create an array of this L1 and L2, A is equal to A1 is equal to np array of L1, and A2 is np dot array of L2, and let's say L1 times, let's print this one, print L1 times 5, and then see what's the result. So as you can see, it is repeated 5 times. This is the first list, and then for 5 times they are repeated. But if I want to say the print for A1 times 5, let's see what do we have in the result. As you can see, all of the member, which is 1, 2, 3, 4, 5 in A1, it's gonna be 1 by 1 times in 5 itself. And let's say if I want to say print L1 plus L2, and the same thing for print A1 plus A2. Let's see what's the difference. As you can see again, L1 plus L2, it put both of the lists back to back. This is the first one and this is the second one. But for the other one, A1 and A2, which are array, they one by one gets a result of adding of these member of these arrays. For example, 1 plus 6, 2 plus 7, 3 plus 8, and we have one single array with 5 member, but the result is the adding up of all of the member of L1 and L2. Okay, I'm going to introduce another array like A equal to np array of 1, 2, 3, 4, 5, and then print array np dot again append this array A, another list like 7, 8, 9. this one for this one. I think, yeah, that should be fine now. Yeah, so you can see 1 2 3 4 5 7 5 to the first one, and then it's gonna be appending this one. This is gonna be appended at the end, like 7 8 9. Then if I want to say a is equal to np dot array of 1 2 3, and if I want to say print ap dot insert of a, and in the tree location of this array, tree location of this, insert this one. For example, 5 6 7, and this is np. Yes, as you can see, instead of this tree in this location, we inserted this one. This is 0 1 2, and after this, in location of the tree, we're gonna insert this one. It's gonna be appending at the end of that. And if I want to introduce another array like this, to say np dot array is 1 1 2 3 for first row, and for second row is 4 5 6, and saying that print p dot delete a and 1. Let's see what do we have. It's gonna be one row, and it deletes the 2, which is the member in position of 1. And let's change it to this. Then it's gonna be deleted that member in position of 1 in both of 2 rows, and it deleted 2 and 5 in 2 rows. Let's change it to 2, for example. If I change it to 2, it's gonna be again one row, but that one which is in position 2, which is a 3, gonna be deleted. And let's introduce another form of the array. Say np dot array is equal to something like that, 1 2 3 4 first row, and for the second row 5 6 7 8, and for the next row I would like to say 3 8, oh god, 9 6 4 7 and 1 and 10, then close this one. Let's change this one to 10 11 12. That's enough. And let's say print np.shape maybe a.shape. Yeah. So it's gonna be 3 rows and 4 column, 1 2 3 4. And let's reshape it. So let's print, for example, a dot reshape, for change it to something like 2 rows and 6 column, to see what do we have here. Okay, it's gonna be changed like this. It has 2 rows and 6 column. All of those things gonna be reshaped to this one. Let's do the reshape in the other way. Reshape it in 20 and this. 20, I should say 12. Yeah, it is gonna be one row. All of the member gonna be in one row. And if I say 12 and 1, we're gonna see something like this one in one column, not one row. Okay, let's copy this array again and do something else. As you can see, just getting flat in one row. And let's introduce another variable, like variable 1 is equal to a dot flatten. And then let's say variable 1 dot, for example, for location 2, we change the value of that, and let's say print variable 1 after this, and print the original A array as well, to see what's the difference now. Okay, for the first one, which is flattening, and then for this one, after we change the variable 1 for position 2 to 100, it changed to this one, and it is flattened as well. But as you can see, the array A hasn't been changed because it is a copy of array A. And let's do the same thing for the other method, like this one. But I change it, instead of the flatten, to the ravel. And let's see what is the difference. Okay, it's getting flattened again by ravel, but once we change the ravel for variable 1 in position to 200, it's going to be changed in the flattened version. But the original A has been changed as well, as you can see, the 100, because it's not a copy, it's just changing the original array as well. Okay, and let's get a copy of this array and do the other method, which is transpose. And let's print a dot transpose and see what is the result of this one. Okay, it's gonna be changed, as you can see. 159, it's gonna be in the row, and it has changed in that way. The other way that we are able to do this one is, just let me get copy and say print a.t. This is the other way that we are able to do the same thing for transposing. Let's continue with the concatenate. I already have two array. Let's bring them in. Two array, A1 and A2, and let's see what is the, or maybe I can just say A equals to NP dot concatenate A1 and A2, and axis of 1, and then print A. Yep, as you can see, it is the row for row 1, 1, 2, 3, 4, 5 for the first array, and continuing with the 11, 12, 13, 14, 15 for the first row, and for the second one, the second row of the first array and second row of the second array gonna be in the second row of the final result. If I want to just do the same thing for the next method, which is a stack, let's do it for the stack. As you can see, the first array, which is here, and the second array is coming after this, gonna be appending to each other. And let's do it for the V stack and H stack. Let's copy this. V stack, no axis. Okay. As we can see, it can be appended to each other. first one and the second one. And if I want to go for the H1, yeah, this is the first concatenate that we did already. It is a concatenate. And let's check for the split. Get the copy of this array I already have here. And then let's print np.split for array into array, and axis is 0. Yes, as you can see, it is 1, 2, 3, 4 rows in the original array, and we wanted to split it in 2 arrays. It's gonna be split in 2 arrays and with 2 rows in each array. The other one, again, copy this one, and let's see what is the min, max, median. Let's print a dot max, and let's get a copy of this one. Control V, min, for this one, np dot median for a. Yeah, as you can see, the max is 20, which is correct. The mean is 1, which is correct. The mean is 10.5 and the median is 10.5. And the last one that I want to cover in this video is random. I'm introducing number variable is equal to np.random.randint for range of 100, and then let's say print number. That gives us 81 in this range. Let's copy this one and say the size is equal to 2, 3, and 4. Yes, and it will give us a 2 array in each 3 rows with 4 columns, and the number are in the range of lower than 100. Thank you for watching.